Certification readiness is more than passing an audit. It means your AI solution, management system, risks, controls, evidence, and improvement actions all tell one coherent story. In this capstone, we turn implementation work into an audit-ready ISO IEC 42001 package. By now, the main pieces are in place: foundations, governance, architecture, operations, and implementation evidence. This module brings them together into a certification readiness package that executives, delivery teams, auditors, and assessors can review with confidence. The readiness package turns and aims from a set of internal activities into a clear certification story. It brings scope, AI systems, risks, architecture, controls, monitoring results, evidence, and improvement actions into one trusted place. Its value is traceability. An auditor can see why a risk matters, which controls address it, how those controls are implemented, and what evidence shows they are working. Leadership gets the same benefit: a practical view of readiness, open gaps, and the actions needed to move towards certification. Think of the readiness package as the audit story, supported by evidence. It begins with scope, the AI systems included, and the risk and impact picture. It then explains how the system is built and controlled through architecture, lifecycle documentation, applicability decisions, and control mappings. From there, it shows how the system is operated: monitoring, incidents, human oversight, and performance criteria. The final piece is the evidence index, which connects each ISO IEC 42001 requirement and selected control to proof. Without that linkage, documents are just files. With it, they become audit-ready evidence. An aim starts with a simple question: what exactly are we governing? The scope statement sets boundaries around business functions, AI use cases, stakeholders, locations, platforms, dependencies, and lifecycle stages. The inventory turns those boundaries into auditable records for each AI system: who owns it, what it does, what data it uses, where it sits in the lifecycle, and how much risk it carries. These two artifacts must align. If something is in scope, it needs control coverage. If it is excluded, the reason must be clear. That alignment prevents gaps during audits. Risk assessment looks at what could go wrong with the AI system: bias, leakage, hallucination, unauthorized access, drift, misuse, or reliability failure. Impact assessment looks at who is affected and how seriously: individuals, customers, employees, regulators, and society. The value comes from connecting the two. Each significant risk should lead to a treatment decision: avoid it, mitigate it, transfer it, accept it, or continue monitoring it. For high-impact risks, that decision must trace into real safeguards, such as architecture controls, procedures, metrics, oversight, and audit evidence. The applicability matrix turns ISO IEC 42001 from a checklist into an operating model. For each annex control and any AI-specific control you add, record whether it applies, why it applies, how it is implemented, who owns it, and what evidence supports it. Then map that control to the actual architecture: data pipelines, model registries, prompt gateways, monitoring, access controls, and review workflows. This creates traceability from governance expectations to technical safeguards. It also clarifies accountability, because security, engineering, data, legal, operations, and governance teams can see what they own and how implementation will be proven. An architecture diagram becomes audit evidence when it connects system design to the controls that reduce risk. Auditors should be able to trace data from ingestion through validation, feature creation, training, evaluation, deployment, inference, and monitoring. At each stage, show what prevents misuse or failure: approval gates, access controls, model registry records, audit logs, human review, explainability, and rollback. For GenAI, include prompt management, RAG, content filters, model access gateways, and output monitoring. The goal is straightforward: make governance visible enough that an interview can follow the controls end to end. A monitoring plan turns post-deployment oversight into a repeatable operating loop. Start by defining what healthy means: performance, drift, bias, explainability, hallucinations, toxicity, latency, availability, and security signals. Then set thresholds, alert rules, review cadence, escalation paths, and clear owners. When a signal crosses a limit, it must feed real processes, such as incident response, risk review, retraining, change control, or management review. Finally, keep the evidence. Dashboards, logs, alerts, tickets, review minutes, and improvement decisions show that monitoring is not theoretical. It is active governance in operation. An evidence pack is not just a folder of documents. It is a traceability system. Each item should connect a clause or control to a risk, an AI system, an owner, a date, and a repository location. Include design evidence, such as policies, procedures, architecture diagrams, and approvals, as well as operating evidence, such as logs, tickets, reviews, dashboards, and monitoring records. The key audit question is simple. Did the identified risk lead to a control? Was that control implemented? And is it still working? Keep the pack current, version controlled, access controlled, and aligned with retention rules. An audit readiness narrative turns evidence into a clear operating story. It starts with leadership commitment, defines scope, roles, policies, and governance forums. Then it follows each AI system through identification, assessment, approval, deployment, monitoring, change, and retirement. What matters is cause and effect. Risk and impact assessments shape architecture decisions, required controls, oversight routines, and evidence collection. Everyone should be able to tell the same story, from executives to data scientists and operations teams. That consistency helps auditors see not just documents, but a working management system that learns and improves. Certification answers need to connect governance intent to engineering reality. It is not enough to say, we control model changes or we monitor outputs. Explain the chain. The policy requires approved, traceable AI behavior. The architecture uses approval gates, a model registry, lineage, prompt controls, secure APIs, monitoring, and audit logs. The implementation defines thresholds, owners, tickets, and reviews. The evidence shows those controls operating. Strong architecture control demonstrations name the mechanism, the risk it treats, where it runs in the pipeline, and what proof an auditor can inspect. Certification readiness also depends on proving the aims learns from evidence. Monitoring data, audits, incidents, stakeholder feedback, regulatory changes, and model performance all become inputs to management review. Leaders decide what must change, assign accountable owners, and approve action plans. Each action needs a due date, priority, risk reduction reason, and completion evidence. The important part is closing the loop. Lessons learned should update policies, architecture standards, lifecycle controls, training, and future AI system design. That feedback loop shows the system is actively managed, not just documented. The final review is where assessment becomes execution. Confirm the remaining gaps across documents, implemented controls, evidence quality, monitoring coverage, ownership, and management review records. Then prioritize them by risk, certification impact, effort, and dependencies. A strong improvement plan is specific. Each action has an owner, due date, resources, acceptance criteria, and evidence required for closure. The outcome should be a clear readiness decision. Ready, conditionally ready, or not ready. Most importantly, that decision must be defensible, tied to facts, and supported by a practical path to closure. You now have a practical path from AI governance design to certification readiness. The goal is a traceable package that brings together scope, inventory, risks, impacts, controls, architecture, monitoring, and evidence. Pair that with a clear audit narrative, close residual gaps, and prove effectiveness. From here, move into final remediation, audit preparation, certification assessment, and continual aims improvement.